Now that you've seen one example of a full formal hypothesis test, I'm going to take a step back and talk about some of the ideas involved. The reject or fail to reject. It's weird because you're trying to prove yourself wrong. Most of the time, the alternate hypothesis is what you're trying to prove. But instead of trying to prove it, you're trying to disprove the opposite. What? One way to think about this is it's like a trial. When somebody is put on trial for, say, murder, the null hypothesis, what's the null hypothesis in a criminal trial? Innocent. The null hypothesis is innocent. The alternate hypothesis is guilty. So the prosecutor is going to set out to prove that this guy can't possibly be innocent. That's just completely implausible. So the two verdicts in a trial are guilty or not guilty. Now, if someone is found not guilty in a trial, does that necessarily mean that he didn't do it? No. It just means that it couldn't be proven. Either you manage to show the guy can't possibly be innocent, or you fail to convict. Doesn't necessarily mean he's innocent, but you can't prove otherwise. So that's the idea behind the reject versus fail to reject. That's the only language you can use. No accepting going on. The other thing I want to talk about is the p-value. Remember, the p-value is what we found in step 3 from the table. It's a probability, but what exactly is it the probability of? You might be tempted to say, well, it's the probability that the null hypothesis is true. That's not exactly what's going on. The p-value is the probability that the experiment would have turned out this way if the null hypothesis were true. The p-value is assume that the null hypothesis is true. So the p-value is the probability that experimental results this surprising or more surprising would have happened if the null hypothesis were actually true. It's kind of the probability of coincidence, but not quite. So let's do another hypothesis test. The mean weight of deer in a particular region is 119 pounds with a standard deviation of 21 pounds. Let's say we've established this over a number of years. And a scientist wants to know if it's changed recently. So she goes out and find some deer. She's able to find 56 of them, and they have a mean weight of 104 pounds. And we want to know, has the true mean changed? What's the first step to doing a complete formal hypothesis test? That's right, we need to name the hypotheses. Ho and ha. What's the null hypothesis? That the mean has not changed. It's still 119, and she just happened to get some skinny deer. The alternate hypothesis is that the mean has changed. You cannot say alternate hypothesis is less than because there's no direction word given. She did not say, I think the deer are skinnier, let me test that. She just said, I want to know if there's been any change in the weight of the deer. She didn't know which direction the change might be until she did the experiment. So, these are your hypotheses. What's next? Yep. You gotta find Z. And then look it up on the table. What's our sample mean? 104. Ooh. So sample mean is 104, population mean is 119, standard deviation of 21, sample size of 56. We have a z-score of 5.34. This is a really remarkable z-score. What's remarkable about it? Actually, it's negative 5.34. Whatever. What's remarkable about this z-score? The fact that it is not on the table. What do we do when we come across a z-score that's not on the table? You assume that it's 0.0001. It is very, very small. Now, because we had, this is a two-tailed test. A two-tailed test means that change in either direction would be interesting. If the deer have gotten much skinnier, that would be interesting. If the deer have gotten much bigger, that would be interesting. That's why it's a two-tailed test. Now, when it's a two-tailed test, this is very complicated. You need to multiply your table value by 2. Think we can handle that? Good. So this is my p-value. Is that a small p-value? Oh yeah. This p-value is like so small that you can't even see it. It's not even a P at all. It's like a little, sort of a corner that's still attached to the thing after somebody pulled it off. Very, very small p-value. So what happens to the null hypothesis? Step 4 is to make a decision about the null hypothesis. Are we going to reject it or fail to reject it? Yes, we're going to reject the null hypothesis because the p is so very small. And when your p-value is this small, you can reject it with some force. It's not a polite rejection. It's a don't let the door hit you on the back on the way out. The null hypothesis, we don't need them anymore. So we reject the null hypothesis. What does that mean for the deer? Have the deer changed in weight? Yes. The mean weight of deer has changed significantly. The deer have lost weight. They have gotten skinnier. You're like, but we knew the deer changed weight. They used to be 119 and now they're 104. What we did here was we proved mathematically that the change was too big to be plausibly explained by coincidence. You know, if we'd gotten like 117 instead of 119, that would maybe be a coincidence. But a drop of 15 pounds, given our sample size and standard deviation, the decrease is just too big to be a coincidence. That's one good way to think about what a hypothesis test is all about. You're trying to answer the question, could this have been a coincidence? Anytime you think you see a pattern, you should ask yourself, could this just be a coincidence? That's what the null hypothesis is saying. Ho says, oh, I bet it's just a coincidence. Ha says, no, I bet this is important. I bet there's something interesting going on here. So the null hypothesis says it's just a coincidence. The alternate hypothesis says the deer getting skinnier is important. I don't think it's a coincidence. And the p-value is what you use to make the decision between them. Because our p-value is very small, the null hypothesis really doesn't have a leg to stand on anymore. So this researcher could go to the government and say, hey, the deer have gotten much smaller this year. What's going on? Why is this happening? Why are the deer smaller? Of course, that would take another experiment to figure out why the deer are smaller. All this one has proved is that the average weight has decreased by an amount too big to be a coincidence.